we will be adding two numbers. Of course, it's A plus B is equal to C. We will define some constants. Our A will be 2. Our C, our B, rather, will be 4. And our C, well, we'll figure that out. We will use R1A R2 is B. And R3 will be our result. So we will load immediate R1 as 2, load immediate R2 as 4. We will load immediate R3 as 0, just to zero it out, to be 100% certain. We will add R3 will be our result. R1 will be our A, and R2 will be our B. And of course, we must terminate execution. Two plus 4 is 6. But now we have two registers that are not being used anymore, and we have one result register. Alright, so next we're going to learn about something called constant propagation. Because A and B never change, we can reduce the amount of registers that we need. First of all, B is here, so we will replace it by putting 4 and attempting to compile. But we see an error. This token is not expected. That is because in this version of assembly, you must differentiate between add and add immediate. And if we do this, we still get the same answer, but R2 is still 4 because we set it to be 4 here. If we comment this out, we can see that we saved one register. One register might not sound like a ton, but if you're doing a lot of addition, for example, that could be the difference between not having enough registers and having enough registers.